Hey everybody, here is the Chapter 5 review video for Math 3. Number 1, it says g of x equals -2 times x minus 3 cubed. I did this one in class, but here it comes again. Try it on your own real quick. If you want to try it, pause the video, try it. All right, here it goes. So there's two ways to do it. One is to write out the steps. Another way is to switch the x and y. So let's do the steps first. So the steps means you identify what steps were taken in the function and in what order. So you start by looking at the x and seeing what was done most immediately to the x. And we have to follow PEMDAS. We have to follow the order of operations. And so what's inside the parentheses comes first. And so that would be -3. So step 1 was that we subtract 3. Step 2, after parentheses comes exponent, and so that exponent is cube. So we are to cube it. And then the third and final step is that all that gets multiplied by -2. 3 multiply by -2. And so if we want to find the inverse of the function, and I'm sorry, that's what they want. I need to label that properly. Right, that is the question. What is the inverse function of x? Well, if we want the inverse function and we write out the steps, we have to go backwards and do the opposite, because that's what undoing a function is. We're going to undo the function. We're going to go backwards in reverse, undoing the steps. So that means step 1 is the opposite of step 3, and the opposite of multiply is divide. So we're going to divide by -2. And then the second step is that we will, what's the opposite of cubing is cube rooting. So the opposite of cubing is cube rooting. So we're going to cube root it. Cube root it. And then the third step would be the opposite of subtracting 3. So we're going to add 3. And what does that look like? Well, what that looks like is if you have an x, then the first step is divide by -2. Okay, we divide by -2. And each successive step does its operation to the entire function so far. So we have to cube root the whole thing. We're going to cube root all of this. And then the third step is to add 3, not inside the cube root, but to everything. So we just have to put a +3 on the outside. And this would equal the inverse function of x. The other more mathematically common way that I would say most math people use is they just replace the g of x notation with a y. And so they rewrite the equation as y equals -2 times x minus 3 cubed. And then to find the inverse, they simply switch the x and the y. So this means that we now have x equals -2 times y minus 3 cubed. And if you just put that down, I would probably give you some credit, because that is, in fact, the inverse of the original. Like I would, if you put that down, if you put that into Desmos, you will get the graph of the inverse. And if you need to find particular points on the inverse graph or some such, this would do the trick, and it would be totally sufficient to do that. So I would definitely give you some credit. But if you do want to do it properly and get full credit, you need to isolate y. And so to isolate y, well, it's kind of like the steps method, but I think it's slightly more intuitive, but you can disagree. So we have to get the y by itself, so we have to get rid of the layers around it. And so the way we get rid of layers around it is by doing the opposite. So that means, for example, we have to divide both sides by -2, because I'm trying to get at the y, and the y is in there, and I have to take the outer layers out until I can get to the rich, creamy y center. So I'm going to divide both sides by -2, and I get x over -2 equals y minus 3 cubed. Okay. Now, again, I want to get at the y, so I got to get rid of those brackets. So I got to get rid of that cube on the outside. And the way to get rid of it is to cube root it, because cube rooting is the opposite of cubing. And so what that gives me is this gives me the cube root of x over 2 equals y minus 3. And the brackets have dissolved because I cube rooted a cube, and that just ends up where you started. So now to get rid of the y by itself, all I have to do is remove that -3, and I do the opposite there. And so I add 3 to both sides. I'll use a blue pen. Plus 3 over here and plus 3 over here. These will cancel, leaving y by itself. And so I get that y equals, and I will copy this over, the cube root of x over 2 plus 3. And you'll notice that these are the same. Because again, the whole point is you can use whatever method you prefer. You should end up at the same place. And that is how you find the inverse of a function. One more example. I'll do this one more quickly. I'm not going to do both steps. This one says, both methods, I mean. This one says f of x equals -5 minus 7/3 x. Take a minute, try it, do it, go. Okay, great. So here's how it goes. I'm going to use the more traditional math method, and I'm just going to switch the x and y's. And so this will become x equals -5 minus 7 over 3 y. And again, the goal is to isolate the y. So the first thing to isolating the variable is to get rid of the terms that don't contain the variable. In this case, that is -5. -5 does not have any y's. It's got to go. Because again, remember, we want to get the y by itself. The -5's got to go. And the way you make it go is that you do the opposite. What's the opposite? Well, it's -5. So the opposite of -5 is +5. So we're going to add 5 to both sides. Okay, and that gives us a nice x plus 5 plus 5, and that equals -7 over 3 times y. And now we're only one step away because we have to simply get rid of that coefficient next to y. It's being multiplied by y. There's a hidden multiplication sign here that maybe you hopefully knew, but maybe not. And so the opposite of multiplication is division. So we would like to divide both sides by this fraction. But maybe you remember from back in the day that when you divide by a fraction, oh, that's actually the same as multiplying by the reciprocal. Do you remember that? Dividing by a fraction is the same as multiplying by its reciprocal. So we are going to multiply both sides by 3 over 7. -3 over 7, I should say. -3 over 7. Okay, let's do that. So here we have our bracket. I unfortunately painted myself in a corner, but I think I can manage to get out. So we're going to multiply this by -3 over 7. I hope you find that successful. And we're also going to multiply this by -3 over 7. The 3's cancel, the 7's cancel, the minus cancels, and we're just left with our y. This over here, you should probably distribute it and simplify. Some people might call this okay. I would probably give you credit for it, but let's just be proper and thorough. So again, this gets distributed to both. So we have negative 3 over 7x plus negative 3 over 7 times 5. Which is negative 3 over 7 times x minus 15 over 7. And that is the inverse of that function. Number 3, that was number 2. Here comes number 3. Number 3 says, state if the given functions are inverses. Okay. Well, the first one says f of x equals minus 3 plus 2/3 x. And the second one is h of x equals minus 5x. And immediately I become suspicious because we have none of the same constants. We have a 5 now instead of a 3 and a 2. But maybe there's something I'm missing. So traditionally, we could now do exactly what we did on the last two problems, which is to go through the steps to find the inverse of each and see if they're the same. Or switch to x and y, and see if that works out. Or we can just plug in numbers and see if that works. However, I'm going to take the liberty and say that these are not inverses, simply because what is the inverse of h of x? I think that's the easier one here. The inverse of h of x is only one step. The step is multiply by negative 5. And so the opposite would be to divide by negative 5. And so that would look like this. And so the inverse function of h of x equals x over negative 5. I don't know what this is, but it's not that. It is not that. And so I'm comfortable saying no. These are not inverses of each other. Number 4 says that f of x equals the cube root, trying to draw a proper 3, cube root of minus x plus 2 over 2. Minus x plus 2 over 2. And the second one is g of x equals minus 2x cubed plus 2. And so once again, the traditional method would be, hey, let's find inverses of each and see if that is in fact what it is. However, there was another way that I taught you in class, and that is to actually plug in a number and see what output you get, and then plug that output into the other function. If that other function gives you back the original input, then they are likely inverses of each other. And then if you try it the other way around and find the same thing, then they're definitely inverses of each other. So let's try something. I said not to pick one. That's probably still a good idea. I'm tempted to pick 2, but there's a lot of 2s here, so I'm kind of like, maybe not. Let's just try 3. Let's plug in 3 for x and see what happens. So f of 3 equals, again, the cube root of negative 3, because we just replaced the x with 3, plus 2 over 2. And that gives us the cube root of negative 1 over 2. And I'm just going to leave it like that because there's not much we can do here. I mean, I suppose negative 1, we know the cube root of that, but I prefer to just leave it as is. which really sucks. But, you know, hey, let's plug it in. I realized maybe I could have picked a better number, but we're going to plug this in for X. Sometimes that happens, right? You pick something and, you know, what do you know? Like maybe, how do you know what to pick? Sometimes you just pick and it's not great. And that's kind of part of the game. Yeah, that's part of what happens. You just got to roll with it, especially if you're in a crunch for time. So what is it? Well, we have -2, and we're going to replace X with the cube root. Let me make this color-coded here. With the cube root of -1/2. And this is supposed to be cubed and then +2. And so if this is in fact cubed, then this stuff here resolves with the 3, and we're just left with -2 times -1/2 plus 2. And this part over here, the minuses cancel. 2/2 becomes 1, so this becomes 1 plus 2. Hey, we got back our 3, which was the original input. And so I'm tempted to say, yes, that worked. But maybe, you know, maybe you're, and I'm sure a lot of you are thinking, yes, I'm good. We can move on, Mr. Schellenberg. But just to be safe, and because I have the time, let's try. So let's pick a different number. Let's say like 4. Again, these are arbitrary. G of 4 equals minus, let me keep the color coding, -2 times 4 cubed times 4 cubed, and we're just cubing the 4, not the 2, the -2, and then plus 2. 4 cubed happens to be 64. I told you guys to remember that one. And so we have -2 times 64 plus 2, and that is -128 plus 2. I'm wondering if I'm regretting this number. -126. And so let's plug it into the f function. And so we have the cube root of -x, which in this case would make it positive 126, plus 2 over 2. I should really keep this red. That's a 2. And so this gives me the cube root of 128 over 2, which is the cube root of 64, which is 4. I'm good. Definitely these are inverses of each other. Wow. Hey. And that's how easy it is. All right, let's keep going. So the next couple of questions, 5 through 10, have to do with operations and functions, adding them, subtracting them, multiplying them, dividing them. And so let's begin. Number 5. Number 5 says that we have f of n equals 2n minus 1. G of n equals 3n cubed minus 2, 3n cubed minus 2. And they want to know, what is f of n minus g of n? Well, that's very straightforward. F of n is just 2n minus 1. And then we have minus g of n, which I'll make green, which is this right here. So this will be 3n cubed minus 2. And this is where everyone screws up. They forget that that minus was not part of either function. This minus was already there. And so therefore, it belongs to the entirety of g of n, meaning that we have to distribute this negative to everything inside those green brackets there, where the g of n is. So this minus distributes to this term and this term. And that means that this is 2n minus 1 minus 3n cubed plus 2, because 2 minuses make it positive. Let's just combine like terms, and then we'll be done. What's like? Well, this is like with this, and that's it. So we have minus 3n cubed plus 2n, and then 2 minus 1 is 1, so that's plus 1. And that is your answer. If only my handwriting were better. Let's make this look a little prettier. This is supposed to be minus 3n cubed here. Just a little bit better. Okay. Minus 3n cubed plus 2n plus 1. Number 6. Again, try it on your own first. Actually, let me tell you what it is before you do that. Number 6 says that g of x equals 2x plus 2. Come on, give me a plus. And h of x equals negative 2x cubed plus 4x. Ugh. Well, all right. Negative 2x cubed plus 4x. Sheesh. And they want to know what is g times h of x. What is that? Well, remember what that means. All this means right here. Let me rewrite this. This means g of x times h of x. This is just a dot. This is not the open circle, which means composite. This is just a dot, meaning multiplication. I'm trying to make it just a dot. Okay, I had it good already. Why did I have to mess with it? Okay. So what is that? Well, that just means we have to multiply the two functions. So I recommend area model. You could also use FOIL in this case because they're both binomials. But let's do area model because that's something we've talked about and I think you guys kind of need to know. And so let's try to color code this as well. 2x plus 2. So we'll make this right here 2x and plus 2. And we'll make this one right here this stuff right here. So we'll have minus 2x cubed and plus 4x. And then we start multiplying. 2x times negative 2x cubed. Well, this is 2x to the 1. There's a hidden 1 here. And x to the 1 times x cubed is x to the 4th. Because whenever you multiply numbers with the same base, you add the exponents. So if you want to think of it another way, this is minus 2 times x times x times x times 2 times x. And so the constants go together and the variables go together. So this will give me minus 4x to the 4th. And then in the top right, we just have a positive 2. So this becomes, we just multiply this by 2. So we have minus 4x cubed because minus 2x cubed times 2 is minus 4x cubed. On the bottom left, we have 2x times 4x. So that gives us 8x squared because x times x is x squared and 2 times 4 is 8. On the bottom right now, we have 2 times 4x. 2 times 4 is 8. So this just becomes 8x. Are there any like terms? There are no like terms. So if you don't mind me erasing this here, just so I get some room, that means that g times h, g of x times h of x equals negative 4x to the 4th minus 4x cubed plus 8x squared plus 8x. And remember to put them in descending order of their variable, the exponent on the variable. And that is the answer for number 6. Number 7. Number 7 is division. So we have f of x equals 3x minus 3. And we also have g of x equals x cubed minus 5x squared. And they want to know, what is f of x divided by g of x? F of x divided by g of x, they say. And so in my mind, we just put these on top of each other. So we have 3x minus 3. And this is supposed to be divided. Sorry if it doesn't turn up right. It looks like a minus. That's better. So we have to divide this by g of x, which I will circle green. And so that will be x cubed minus 5x squared. And at this point, you want to see, hey, is there something we can factor out here? Like, does the numerator and the denominator have any common factors? Can we simplify the numerator denominator and factor something out and maybe see if it simplifies? You can try all that. It's not, so for the purpose of this test, they're not worried about you simplifying that. That's really, we're not dealing with dividing polynomials so much and splitting it up. Your hunch is correct, but in this case, there's nothing you can do. And the ones on the test are like that as well. We're not here to simplify this fraction beyond what this is. We just want to establish that you know, if I divide functions, what that means, what that looks like. That the one is over the other, the first one is over the second one, just as we have here. That's what they're asking you to do. That's all we have to do. This is our answer. Side note, you could factor out a 3 on top and an x squared on the bottom, but then you'll see there's nothing to do. Number 8. Number 8 says, this is a composite function. So here we have f of t equals minus t plus 5. And g of t equals t squared plus 2. And they want to know f of g of t is what? Remember what I said? You always start on the very inside, right? If you have a composite function, you have a function within a function. You start with the function that's on the very insides. In this case, that's g of t. So we're going to look at g of t right here and substitute. Well, what is it? Well, g of t, isn't that the same thing as this? They're equal to each other. So they're the same. So I'm just going to go ahead and substitute it. Just because, what else are we going to do? And you know, we're trying to resolve the function and to put something in its place. So this becomes t squared plus 2. And now we have to plug this into the f function. Remember what the little bracket means next to the function, next to the f? That means the value that you're inputting into the function. So whatever goes in the brackets is what you are inputting into the function, meaning you're going to replace the t with whatever's inside those brackets. Because the t got replaced in the bracket, so the t outside the bracket also needs to be replaced with the same thing that you replaced inside the bracket. So t squared plus 2 is going to go in place of t. But everything else has to stay the same. So that means that, I wish I'd moved it over a little bit, but that's okay. This is minus t plus 5, right? Minus t, but t is actually t squared plus 2 now, plus 5. Notice how this function, this f function here, is the same thing as this. The only thing that changed is I replaced t with t squared plus 2. Why? Well, because that's what g of t is, and that's what we found here. So we're just going to replace that. And now it's just a matter of simplifying. So we're going to distribute this negative to both terms inside the bracket, and that will become minus t squared minus 2 plus 5. And of course, minus 2 plus 5 is positive 3. So this becomes minus t squared plus 3. And that is it. That is the answer. Okay, so to answer the question, f of g of t equals minus t, equals minus t squared plus 3. And that is the answer. Number 9. Number 9 asks for another composite function, but this one, the notation is different. So hopefully you remember what that does, what it means. So here's what I mean. So like it says f of n equals 2n plus 4, and we have g of n equals 2n minus 5. And they want to know f and this little circle g of negative 5. And what does that mean? Well, I said in class that this is just another way of writing the composite function of one function inside the other. The first one is on the outside, and then the ones after that are on the inside of that, meaning that this is f of g of negative 5. That's what this means. So, and we're trying to find this right here. And as I stated before in class, you start with the very inside, because you can see g of negative 5, and so we can figure out what that is. So we have g of negative 5, and that means we're going to place n with negative 5. So we have 2 times negative 5, right? And then minus 5 is still there. What does this equal? Well, this equals minus 10 minus 5, because 2 times minus 5 is minus 10. And so this right here equals negative 15. Once we have that, we have now resolved the inside bracket. So that means that this is the same thing as saying f of negative 15. Because g of negative 5 equals negative 15. And so I can replace the g of negative 5 with a negative 15. Which brings me to my final function, f of negative 15. So let's do the f function, f of negative 15. And we're going to plug this into the f function. So it's 2 times negative 15, because we're just replacing the n with negative 15, plus 4. This gets distributed. That is negative 30 now, plus 4. And that, of course, gives us our answer, which is negative 26. So that means this is negative 26. And that is our answer. Number 10. Should I really do all of these? I feel like skipping one. But I've done all of them so far, so I feel like I can't skip out. It's like cowardice. So g of a equals 4a plus 3, and f of a equals a squared minus 5a. And they want to know g of f of 5. Okay, and we know that equals g of f of 5, like this. And so we want to figure that out. So again, we start with the inside function. Actually, take a minute. I keep forgetting to say this. Take a minute, try it on your own. Go. Here's the answer. I keep wanting to say that. I keep forgetting. F of 5. Okay, let's find out what f of 5 is. So we're going to take the f function and replace the input value with 5, because that is our input. And we're going to replace all of the variables here that were the original input with our 5. So this a becomes a 5. 5 squared minus 5 times our input value, which is 5, and see what we get. 5 squared is 25 minus 25, and that is 0. Okay, so that means that I shouldn't block that off yet. That means that this is equal to g of, well, what's f of 5? Well, f of 5 equals 0. This right here equals 0. So this equals 0. And now we have to find out what g of 0 is. So g of 0 equals 4 times 0 plus 3. I just took this function up here and replaced the a with 0, which is this right here. 4 times 0, well, that's just 0. So this is 0 plus 3, and that's 3. And that's our answer. And that was number 10. Number 11. Now we get to the interesting stuff. This is where the fun begins. And hey, it's only been like, I don't know, I can't tell the time, but maybe like half an hour. So we have number 11. And number 11 says that 1 over 64 to the power of 1 minus 2n, lovely, equals 16. Try it. Take a minute. See if you can do it. Go. All right, here we go. So, couple ways to do this. You know, we've been learning logarithms, and we learned, you know, about rewriting the exponent and all that, and we could definitely do that here. In fact, I'll show you what that would look like. I don't like doing it because I think there's a better way to do it, but I will show you just because, you know, I'm a teacher and, I like to teach you things. So what this would look like in a logarithm is you always have the base, the exponent, and the other stuff, the result. And so the base is always the stuff at the base, you know, under the exponent. So here that would be 1 over 64, which is really kind of funky. You know, we're not used to seeing those things in the denominator, but math is math. And the exponent, remember, the point of logarithms is to isolate the exponent. So the exponent actually goes over here. So 1 minus 2n goes over here to the right. And that 16 stays there on the logarithm. I just don't like how this came together. That's a little better. And that's what you would do. And that's really, I mean, yes, you can do it. I shouldn't knock it. You can plug this into the calculator. You know, you could take this and plug this into the calculator. It will give you a constant. It will give you a number. And then you just solve for n. And I'm going to have to do it, aren't I? I know you want me to do it, don't you? Gosh darn it. Okay, but I'm not going to share my Desmo screen. Let me just punch it into Desmos myself, and I'll tell you what that becomes. So in my calculator, I'm going to plug in a base. I'm going to go in my calculator, and I'm going to have the log with the a at the bottom. I'm going to click on functions, and the log, go to miscellaneous, and the log with the a at the bottom, because the a at the bottom means I can change the base. And as the base, I want 1 over 64, which is also known as 0.01565. And it's of 16. So that goes in there. And wow, you know what? That turns out to be minus 2/3 equals 1 minus 2n. So I just plug that red box into Desmos, or any other calculator is fine. And I plug that in, and I got minus 2/3. And now I can solve for n. And so I don't like negatives, so I'm going to add the n to the other side. So I have 2n minus 2/3 equals 1. And then I'm going to add 2/3 to both sides. And that's going to give me 2n equals 1 2/3. Or you can rewrite 1 2/3 as 5/3. Divide both sides by 2, and I get n equals 5/6. And that is my answer. And maybe that's good enough for you. Now, I told you I actually prefer to do it a different way. Here it comes. Maybe the right way, maybe the one on the right is better for you. Maybe that's better for you. But anyway, here, you can ignore me, but here goes the other way. It has to do with memorizing some numbers, like 64 is 4 cubed, and 1/64 is 1/4 cubed, otherwise known as 4 to the negative 3. So what I'm saying is that I know that 4 to the negative 3 equals 1/64. And that knowledge helps me to see some things, because I recognize that 16 is also 4 squared, meaning they have the same base. And if they have the same base, that's going to be really good for me to compare. And so I'm saying, hey, let's instead of 1/64, let's write 4 to the negative 3. And instead of 16, let's write 4 squared. Why would I think of this? Well, number one, because I can. Because I see, they both be 4. Sometimes I don't even know. I'm just like, well, they both have a base of 4. Maybe that's how I solve? I don't know. Let's try it. So I try it. And oftentimes I'm rewarded for that hunch. In fact, I would say usually I'm rewarded for that hunch. So let us go down that hunch. So we have 1/64, but I'm going to write instead 4 to the negative 3. And this is to the power of 1 minus 2n. And this equals 4 squared, because 16 equals 4 squared. Now what? Does this help us at all? How am I supposed to know? Well, whenever we have bracketed exponents, or if you watch my video on exponents that I posted back in August or September, when you have bracketed exponents like that, you have to distribute the exponent to all of the exponents within the bracket. So this becomes 4 times negative 3 times 1, which is minus 3, and negative 3 times negative 2n, and that is plus 6n. Let me try to clean this up a little bit. And this is supposed to equal 4 squared. Well, the beautiful thing about this now is that means that minus 3 plus 6n equals 2. Because the bases are both the same, and it's an equation that's equal to each other. Let me get some separation here. And so the bases are the same, and it's an equation, so they're supposed to be equal. So that means that minus 3 plus 6n has to equal 2. And so I will go ahead and add 3 to both sides, and I get 6n equals 5. Divide both sides by 6, n equals 5/6. Hey, that's the same answer as the other one. Wow. So there's two different ways to do it. Choose your path. I'm going to move on. The next question is number 12. Number 12 says 8 to the negative 3m. That's an ugly m, I'm sorry. Equals 64. Once again, I'm going to use my hunch. And I'm going to say, hey, isn't this 8 to the negative 3m equals 8 squared? So therefore, minus 3m equals 2. Divide both sides by minus 3. M equals 2 over 3, negative 2 over 3. And that's it. That's the answer. I forgot to tell you to do it on your own. I keep screwing it up. You want to try doing the log? You want to do the log? I don't really want to do the log, but I got to. There's some sense of obligation that I just can't escape. Remember, the base is always the base, so that goes down there. The exponent is always on the other side. So that is over here, and then the 64 goes here. Punch it in a calculator. 8 to what power is 64? Calculator. 2. 2 equals minus 3m. Divide both sides by negative 3. Minus 2 over 3 equals m. Same answer. So maybe I shouldn't knock the logarithm. I mean, it is kind of the theme of the chapter. So moving on. We're getting there, guys. 13. Number 13. Here we go. Number 13 says log of 168 with a base of k. Oh, man. Equals negative 12. Ugh. Oh, they just want it written in exponential form. That's way easier. So just remember the base is always the base, and the exponent is always what we isolated, what we solved for, because the point of logarithms is to isolate the variable to get it by itself. So the variable, the exponent is, so let me circle this here. That's that. The exponent is going to be this right here. So this is minus 12, and it equals the leftover part. And that's it. That's done. Because they just asked for the rewriting. There was nothing to solve. Because they didn't ask us to solve. Did I forget to tell you to try it on your own again? Gosh darn it. This time, try 14 on your own. Let me write it first. Log of 198 with base y equals x. Try it on your own. Go. All right, here we go. How do we rewrite this? Again, the base is y. Okay, and the exponent is always what we solved for. So that goes there. And it equals that other number, which is 198. So you have to make sure you get that order right. 15. Number 15. Number 15. 49 to the half power is 7. Rewrite it in logarithmic form. It can't be that easy, can it? After all that, that's how you, what a letdown. We had some real nice, I think the function stuff was harder than any of this logarithmic stuff. But so rewrite this. Okay, fine. Log. Remember the base is the base, so the base is down here. The exponent is what we solved for, so that goes over here. And then the other number is there. Okay, so just, I don't think color coding is really going to help. I'll just move on. And 5 squared is 25. Real simple stuff. Again, try it on your own. Go. All right, here we are. The base is 5. Because that's always the number under the exponent. That's the base. The exponent is what we solved for. So it goes over here. And the 25 is what's left over. And so that goes right here, and that is it. And that is your review for the test. Now, I said in class, I think some of my classes, I said, oh, there's a HK review question and some other funky stuff. I had another look at the test. That was a different version of the test. This is all there is. Everything I did in this video is exactly what the test is about. So don't worry, there's nothing else funky. Everything that's on the test is what I covered today. So again, it is inverses of functions, confirming whether or not a function is inverse of another, operations with functions, meaning plus, minus, division, multiplication, and then composite functions, meaning functions within a function. And let's see, we have some little exponent stuff with some logarithms, rewriting it in a logarithmic form, solving for the logarithm in Desmos or whatever calculator you're using, and just rewriting exponential form to logarithmic and logarithmic to exponential form. That's all there's on the test. See you guys Monday, Tuesday. Hope this was helpful. Give it a like, share, and subscribe. Donate. No, there's no donate. I'm sorry. But see you next time.